All right, we're back. So we talked about continuous deployment. We have a good example of that on Azure today. But now we're going to switch gears a little bit and go back to Blender, right? So I'm going to abandon some of this stuff right now, and we're going to get back here. But I want to talk about some concepts. So there's some conceptual stuff I may ask you about, right? So let's launch Blender. For those people who are with me, I'm going to go into Blender. Again, Blender being the open source modeling tool that you can download and install. For this one, if you're using a computer without a numeric keypad, it may help you to have a numeric keypad, right? So we'll do a couple things. And to illustrate this, to make it a little bit more fun, I want to do a little bit of basic modeling with you today. All right, so let's do that. Because we're going to have to talk about vertices, faces, and edges one more time, right? And this thing. So I'm using my little portable keypad. Again, attached to my file. Got this from Amazon. It wasn't that expensive, right? But it helps with Blender. All right. So we're going to talk about perspective, the camera, right? Right now, if you look at our basic Blender scene, and I'm going to rotate around the scene by panning around. Notice how we have this camera, right? So if I open this up here, we have some options over here in terms of our rendering. Now, one part is we're looking at this in Blender render mode. I'm not going to change it, but our camera, if I press the M key, it's going to give us the exact position in terms of location, rotation, and scale. Right? So that's what our camera, where it's looking at our scene, and what position it's in. Scale is typically almost always 0 or 1. Okay, cool. Now in Blender, there's a bunch of these tabs, right? But we want the one that looks like a camera. Click on the camera on the right-hand side there. Notice how the lens for our perspective here, right? The lens, it says perspective, right? And take a look at the focal length. This is important if you want to match up the stuff that we have on 3JS with our focal length. What does focal length refer to? If what's the 3JS whatchamacallit, the 3JS mapping. If I was going to talk focal length for 3JS, if I have my camera, what's my 3JS mapping for focal length? What does that translate to in 3JS language? Focal length. Field of view. All right. So if I look at my field of view, right? Field of view from a camera perspective, right now notice that it's 35, right? And what are we using for typically for 3GS? Anyone remember? 45, 50, and it's a good range. I'm going to go into the PowerPoint presentation that I've got up for you. So if you go to up on eCentennial, if you look at week 2, I've already put up a PowerPoint presentation on camera. So if you look at that, here's week 2. And I got a bunch of examples here that I'm going to look at, but let's take a look at not the cube, man. I'll talk about that too. But let's take a look at our lesson 2. Here it is. Under lesson 2, one thing that it really is that's really nice is it talks about field of view here, and one of them is the camera. Let me just get to that. Not sure if it's this one or the other one. Yeah, it is. So here's a great example of a orthographic camera versus a perspective camera. Take a look at this picture. This is kind of a neat thing. I like this one. So this is our field of view, right? This is our angle. We talked about this before. And you've got your horizontal field of view and your vertical field of view. And you've got two things. You've got something called the far plane. I'm going to be testing you on this, guy. So if I ask you about the far plane in a camera, this is what this is, far plane. And here's the near plane. The near plane is when we cut off anything that's being rendered on the screen. So the closer the near plane is, the more you get into your camera, the more you can see. So if this is a camera, and if I bring this near plane closer to the camera's origin, right, then you're going to see more in the scene. The farther I put my near plane, or the closer it gets to the far plane, the less the camera renders. And this is called clipping, right? So it's almost like, what does the camera clip away from what it's seeing? So anything between these two pieces, the near plane and the far plane, is what the camera renders. Okay, that's what a perspective camera looks like. And notice that you've got these lines of perspective that go from the point of origin to your horizontal far plane and your vertical far plane. Okay, that's a nice little diagram they give you in the book. Okay, I think they give you another one for orthographic. And again, orthographic, it doesn't use perspective. Notice that there is no line of perspective. The bottom, here's the far plane as an example, and here's the near plane. The near plane and the far plane are in proportion. They're the exact same size. So when I look at a perspective camera, the objects in my scene, even the edges and the faces, will appear smaller as they're closer to us and bigger when they're farther away, or the other way, the opposite way, right? Depending on what perspective is. An example is if I go to Blender, let's take a look, right? Here's my perspective for my camera, right? Notice how these edges appear to be closer than these edges, and they're not the same size. If I was to change this to orthographic view, let's just change this camera to orthographic. Notice how my camera becomes really massive for orthographic, right? But you really can't see the difference in Blender between perspective and orthographic until you actually render the view. So to render a view in Blender, you have to click this button right here, the little camera button, which is the first tab on the right. And I got to click on render. Click the render button, right? If I click render, it gives you a look of what the final scene would be rendered like, depending on where the camera is, what the lighting is, and you know, the materials that have been applied to the shape, right? So that is what the camera is looking at right now. And if you notice, as an example, you know, it's not all the same size. If I was to physically measure the lines, the edge, this edge, and this edge, compared to this edge and this edge, these edges are actually smaller than these edges. These edges are actually bigger, longer, right? But in real life, it's exactly the same size. They're all exactly the same. It's just the way we're seeing it from a perspective. Even in real life, if I look at an object, right? The objects that are closer to me appear larger, and the objects that are farther away from me appear smaller. But actually, they could be the same size, right? So that's what a perspective camera does for us, right? I can press escape to get out of that mode, by the way. Okay. And if I want to do the command keys to do that, it's command or control enter. So if I press command enter, or control enter, I can render the image in full render mode, right? Blender render. And if I press escape, it'll take me back. If I focus my mouse on here, and I press escape, it'll take me back to editing mode, right? Or my 3D mode. All right, cool. So I've got this piece, my render. Notice there's other options here. Animation, where I can make a movie if I want to, right? Audio, if I want to add that in as well, as other options here. But this is like the actual resolution of my scene. If I want to make mine look exactly 640 by 480, I can change my resolution of my final output right here, 640 by 480, if I want to. I'm not going to do that here, but I could.
So how do you come out from the resolution?
Escape. You have to focus your mouse in the middle. All right. Let's go back to this now. So if I go back over to my camera, which is the third one from the right, here's my camera. Notice that I have a focal length of 35. If I go to orthographic, and then I go back to my camera view here, my rendering view, and click render, now what do I get? It doesn't look realistic, does it? Because each side is exactly the same length, right? They're exactly the same. So whenever you look at an orthographic view, all the edges in the orthographic view look the exact same length. And so too will it be in 3JS, right? If we're going to do a 3JS example, right? So that's one thing we need to know. Also, it looks very flat, right? It doesn't look like a real three-dimensional object. Yes, it's been drawn in 3 dimensions, right? But something looks off about it. And a reason for this is the angle here. This angle looks like it's not 90 degrees. It looks like it's much wider than 90 degrees, right? Look at the angle here, right? That's not realistic looking. If I go back, if I press escape, and I change my perspective view, or the camera projection, here it says lens. In Unity, it'll say projection, right? And 3JS, it's just the type. I'm going to go back to perspective for a second. And if I go back to render mode and press render or command enter, notice that again here, it looks like from our eye, it looks like this is 90 degrees. right? So it looks more realistic. So this is the more realistic view, right? But remember that these sides, and when we actually measure, if I was to actually measure them, they are different lengths, okay? So two different kinds of cameras we're going to mostly deal with. There is a third one in Blender that doesn't map exactly to 3JS, but we'll look at that for a second. And the way to do that, of course, is press Escape. So I'm going to go back to the camera view and click Panoramic, right? And then if I click on go back to the render and press Render, I see something like that looks almost the same with a bit more stretch. That's all that's going to happen. So this view stretches a little bit more into the scene than what we had before. Panoramic. Probably won't be using that view too much in this course. Okay, so let's press Escape here and go back to the camera and click back Perspective. Let's change our focal length to 45 to match up with 3JS. So I'm going to go here and physically change this focal length to 45. There we go. And notice how I have clipping. Here's my near plane where it says clipping, and my far plane, which is end. What am I using? What are the values I have in 3JS? What are these values that I normally use? Is it 0.100 and 100? 0.1 and 100? No, it's 0.1 and 1,000, right? Now this gets very expensive. Why does this matter so much? Why is this clipping? If I put 1,000 in here, what is it really doing? Well, I'm rendering everything, right? Rendering means I'm drawing everything, right? So if I go back to my PowerPoint for a second, let's take a look at this. If this far plane is 1,000 units away from my camera origin, right? That's 10 times the amount that I'm rendering now. It's almost like my cone of reality, right? Almost like I'm looking at a telescope, and everything that I'm looking through the telescope, that small field of view is being rendered, and it's really, really far, right? So if I want to see far away details, like an example would be I'm flying a spaceship, and I want to see the moon in pretty good detail that I've drawn way, way in the back, right? If I really want to see that in real time, if I'm drawing that, I want to extend my far plane as far as I can. The problem with that is it draws all that detail. And sometimes what we do, there's techniques we use in game, we do kind of like levels of detail, or LOD, that we use to kind of say, well, if it's between this and this distance, we have this much level of detail. And if I go from, let's say, the second level of detail to the third level of detail, I can reduce that so that way, as I get closer, I get more detail. There's that as well, right? So we still can see shapes, but we don't see detail, right? Because that takes up a lot of rendering resources, a lot of processor power, right? That's one to know. Let's test this out in Blender and see what I'm talking about here. All right, so I'm going to go back to Blender, and I'm going to leave it as 100, right? And right now our unit, here's our cube, right? It's fairly close to us. Let's duplicate it. How do I duplicate an object in Blender? What's my command? Shift D is the command, right? Here's my cube. I'm just going to float it up here for a second. And notice my location is X, Y, and Z. On the Z plane, it's up. Let's make it about 5 up from the Z plane. And on the X and Y plane, right, I'm going to move it out about 110, 120. Here's 120, and there's 120. Hey, where's my bloody cube? She gone, man, right? And if I render, if I was actually to render the scene, right? So if I press Command or Control Enter, right? Render the scene, right? So I go back here, I'll render. I don't see my cube. It's not in my field of view at all, right? And the reason for all this is because it's cut off, right? So how do I change that? So press Escape, go back into my scene. So I'm going to go back into my camera by clicking on my camera. Here it is. And I'm going to change my, which is really, really important, not this one, this camera right here. I'm going to change my end to 1,000. Press Enter. Now, do you still see it? The answer is no. You wouldn't see it. Why? Because it's way down here, and we don't even have anything applied to it. Let's make that cube. Let's give it, some kind of color. And again, how do I zoom into an object that I've selected? Anyone remember what's the numeric keypad? There's actual numeric keypad shortcut for it. Anybody? It's the dot. It's the decimal. If I press decimal, right, and if I focus in on it enough, oh yeah, let's connect it first. Whoa, there it is, right? It's way over here. And if I scroll out just to see where it is, here's what I'm looking at, and my camera isn't really looking at it. It's just way over here, right? So if I was to rotate the scene, right? And again, there's, how would I rotate the scene? Does anyone remember? If I want to kind of pan around. So if I do this, I can rotate with my mouse, right? So here's what I'm really looking at. And here's this cube way, way over here in the distance, right? So I've expanded it to 1,000 away. I'm going to change my camera. I'm going to kind of come into this cube. Look at my original cube here. And I'm going to press, again, the dot to do that. So here's my cube. Let's zoom out. And kind of zoom out. Now see, I can see my cube way out in the distance, like 1,000 away, right? And this is a great idea. Now I want to move my camera so it's here. And how do I change my camera so it sees what I'm seeing here in my viewport? Remember? Control, Alt Control 0. Or if you go to View, Align View, and if you go Align Active Camera to View, Control Alt Numpad 0, then what's going to happen is you're going to see this. So that's not what I want, right? I want to press the N key here, right? And what I want to do is I want to click on Lock Camera to View, under View, and I want to scroll out so I can see and realign my camera so I can see my far cube. There it is. I'll put it off in the distance over here on the left, right? Okay, cool. I want to uncheck this now, this lock camera view, click N again, press T to give me more space, and then just zoom in so I can see it way here at the top. Notice that it's there inside my viewport. But that's because, and even if I go to render and press render, it's there. I can see it's black, but it's there, right? Now, that's because if I press escape, and if I go back to my camera, and if I go back to this over here, notice that my end is 1,000. If I change this back to 100, gone. Okay, disappeared because it's been clipped. I don't render that anymore. It's only drawing anything between 0.1 blender units and 100 blender units. This thing is more than 100 blender units, 120 away, so it's not going to render it. Okay, so that's near plane, far plane clipping. Okay, anything between the near plane and the far plane, I'm going to render it. My camera's going to draw it. So this brings on the aspect of I can use multiple cameras. I can have one camera that's close. We did this in COMP395 when we did our gun camera. I can have one camera that's close that renders the close objects and one camera that does far objects. And you can layer those two views together to create a composite scene, composite camera view, right? Or multiple camera views where you see two cameras focusing on the gun and a third camera that takes a look at the mini map that can be drawn aside for your game. So that, again, multiple cameras to render the same view. All right? Questions about perspective and orthographic cameras and what's the difference? Here's one more thing before I answer that question, right? Or I'll let you guys answer. If I press the 1 on the numeric keypad, 1, I get what's called the front view. Notice this is front perspective. For me to get a true orthographic looking view, I need to press the 5 button. Where now this gives me a true flat plane. So if I scroll in, I can see that there's a flat plane here on the view, right? Flat plane. And again, if I rotate it, if I go to the 3, notice that it flips to the right view, and 7, this flips to the top view. All of these views are considered orthographic, which means they're flat, right? And that's what the difference is. You see a very flat looking view with an orthographic camera. And so why do we use an orthographic camera? Why would we bother with orthographic cameras in 3D programs? Anybody? So what? Why would I bother? Not just for modeling. But there's another reason. For modeling is one reason. What's another reason that we would use an orthographic camera in a 3D environment? What's the reason? It's a very simple reason. We've done it actually. We did it the first half of COMP305. Come on. 2D games. We can make 2D games with 3D programs, right? We can use a orthographic view, and so we limit our camera to one plane, and so we can make a 2-dimensional game. We can make a 2D game, which means we can make a 2D game with 3GS if we really wanted to, right? And we can use the physics that we get from 3GS and everything else to make a 2D type game, all right? Some tricky camera work, but it can be totally done. All we care about is the X and Y plane. We don't care about the Z plane, or we just take away one of the axes, and we can just work within that plane all together to produce a 2D game or 2D perspective. Questions about orthographic and perspective type cameras, right? It's going to be probably, we're going to talk about it on your next quiz. What's the difference? Put it in your own words. Stephen, what's the difference in your own words between perspective and orthographic? If I was going to say in your own words, what is it?
Perspective at the third dimension.
Okay, so no third dimension. What about else? About Wendell? Give me your own words about perspective and orthographic. If I had an interview and I'm gonna get you a job and say, like, I don't know, in a game studio, and they ask you this question, what would be your own words? Explain orthographic versus perspective camera. 2D versus 3D. What was yours? Flat view versus more realistic view, maybe, right? Realistic is what I want you to use. More realistic when you use perspective view, right? Because you're trying to create almost like what looks like true 3D. It's not true 3D, right? Because our eyes see things in not just that perspective, but we also have a visual depth because we have two cameras right here in front of us. There's a camera on this side and there's a camera on this side. And that's what gives us our depth perception, which this does not have. And that's why when we use things like the Oculus Rift and so on, it gives us a change between both of those views, right? So we see what we perceive as depth. One more thing. How about animation? How does that work? How does that page flipping animation or moving an option work? How does that work for our eyes? There's a specialized term that we use that we kind of use page flipping animation to kind of overpass or surpass there's a blank. What would it be in order for page flipping animation to work, right? Frames is what I'm talking about. How do what's the minimum frame rate to make it look realistic? 16. So what does that mean? Or actually, it's about 24, right? 12 frames is really bad. If you see 12 frame animation, it looks kind of rickety. So what am I talking about here when I'm to make realistic animation? It's frames per second, but it's called persistence of vision, right? Human beings have a certain persistence of vision. Anything under 30 frames, about 30 frames per second, we can't tell. If I go from 30 to 60 frames per second, it looks just as good as 30 frames per second, right? In terms of animation, not in terms of functionality, right? Here's the one. Bees have a very, very high persistence of vision. They can see things a lot faster than we can. They can see if they were looking at a screen, they could see the breaks in the camera. Here's another thing that has a higher persistence of vision. Cameras have a higher persistence of vision than us humans. So if you ever see a camera looking at the TV screen, notice we see the lines of resolution. That's because the camera has a higher persistence of vision than we do. All right, so remember persistence of vision. We're going to be talking about that over the course. All right, guys, thank you so much. We're going to be seeing you guys on Wednesday.